And so everything that we say and that you see on my screen, you'll be able to access later. Now,
Okay, cool.
in terms of the material, I have a couple of geometry students at Chatfield, and I got one of them to send me a bunch of stuff that was very, very similar to what we were doing the other day, or yesterday, no, Thursday.
Okay.
But this might be a good place for you to learn how to send a picture to me.
Okay.
We didn't cover that entire test, right? We only got about maybe 2/3
I
of the way
think
through.
we got all the ones that I had missed.
Oh, we did.
Yeah.
Okay, there was nothing on the last page.
No, the
That
last page,
of proof.
it was only a bonus on the last page.
Ah, okay. All right. So we've gone through those. So did you have something different that you wanted to work on today?
Oh, I had 2 questions that I wanted to ask about. So.
Go ahead. Might be able to
All right.
verbalize those, and you don't have to send me anything.
Let me just look for my book to get the numbers up.
Okay. Also, get your calculator. Have your book and your calculator handy, and a pencil.
Okay.
I realize there's something they could give you, and perhaps they do, but that would be very helpful. What you're going to encounter is dozens and dozens of theorems, postulates, corollaries, whatever they call them, and usually these are hard to memorize. You can certainly memorize the essence of the theorem and what it means, but memorizing the exact theorem is tough. It'd be cool if somebody gave you a sheet that had all of them on it at once. And it's worth knowing that the number on the theorem is only the number in your book. It's not even the same number in my book. Your theorem 3.8 is my theorem 3.2.
Well, the 2 questions I had were asking whether or not I could tell whether the lines through the given points are parallel, perpendicular, or neither. And it just gave you 2 line equations, but it tells you not to graph them. So.
Tell me again. I was a little confused as you were going through that.
All right. Well, it gives you the equation, all the points for 2 lines.
Can you verbalize everything to me?
Yeah.
Okay.
Line 1
what are the 2 points?
Line 1 is 8, 12, and 7, -5.
Okay.
And then line 2 is -9, 3, and 8, 2.
What would determine whether line 1 was parallel to line 2 or not?
The slope?
Yes. So let's calculate the slope of both. If they're the same number, they're parallel. If they are not, they're not.
Okay.
If one is the negative reciprocal of the other, then they're perpendicular.
All right.
So what's the slope of line 1?
Line 1, you,
Definition.
do you look at,
Definition.
can you put that?
Definition of slope?
Well, yeah.
What is it?
It's y equals mx plus b.
No. Definition of slope is rise over run. That's what you want to memorize. Okay? Now, what's the rise? If I have something and I want to know the slope of that line, the rise between, say, this point and this point is what? Y sub 2 minus y sub 1. So that's the rise.
Okay.
What's the run?
Is
distance between that point and that point.
Okay.
So what's the run in the denominator need to be?
x2 minus x1.
Right. And this is the official definition of slope. It's just, that's more complicated, and the easier one to memorize is rise over run, as long as you know what the rise means. It means y sub 2 minus y sub 1. And let me say one other thing about this. It's okay to switch it around as long as you switch both around. In other words, it's also y sub 1 minus y sub 2 over x sub 1 minus x sub 2. You get the same slope either way. The one thing you don't want to do is switch one and not switch the other.
Okay.
You'll notice in this problem, it's really a little bit easier arithmetic to do y sub 1 minus y sub 2 over x sub 1 minus x sub 2.
All right.
See why it is?
Yeah, because there's bigger numbers on one side.
Well, you work with less negative numbers. In other words, if I do it strictly by this definition, I'm going to have minus 5 minus 12 over 7 minus 8. There's 3 negative signs in that thing. So if I do it the other way, if I do it 12 minus a minus 5, there's still 2 negative signs in that. In fact, 3, but they're much easier to handle. They don't result in negative numbers. What's the numerator?
12 minus negative 5.
Which is? When I say what's the numerator, yeah, I want you to do the math. 17. And the denominator?
1.
So the slope is 17.
Okay.
And now let's figure out the slope of line 2 and see if it's 17. And that's all we'll need to do.
All right.
So let me erase all of this. When you're trying to let me just say something about memorizing stuff. And this is one of the problems with online as opposed to in person. And that is the best way to memorize stuff is to not have it on a piece of paper in front of you as you're working with it. It's to turn that paper over and see if you've got it memorized. And then try to draw from memory on it. You know what I'm saying?
Yeah.
Okay, so I left the rise over run up, but I erased the specifics. So how would you get the slope of line 2?
8 minus.
Gotta do the y's on top. You can do them in either order, but you gotta have the y's. The rise is the change in the y's. Another way of writing that is change in y over change in x.
So could you do 8 minus negative 9 and 2 minus 3?
8 is an x coordinate.
Okay.
That's the x-coordinate, that's the y-coordinate. That's the x-coordinate, that's the y-coordinate. So you have to start at the back. Always, when you're talking about slope, you start on the right and work your way left.
Okay. So 3 minus 2 and 9, negative 9 minus 8.
What is that? What's negative 9 minus 8?
17.
Negative 17.
Yeah.
Okay. So it's certainly, the slope is not 17, so they're not parallel, but they are perpendicular. Perpendicular means two things. You always have to do two things to find the slope of the perpendicular. And that is, you have to take the reciprocal and you have to change its sign. So 17 becomes 1 over negative 17, which is the same, incidentally, as negative 1 over 17. Doesn't matter whether that negative is in front, on top, or on bottom.
All right.
Okay. And what was your second one that you can, sounds like you'll be able to verbalize? Some geometry you can verbalize easy enough, but of all the math that I've done online, the one that requires pictures the most is geometry, because so much geometry is, they give you a picture and they ask you questions about their drawing, whether it's, you know, triangles, quadrilaterals, circles, whatever.
Okay. So the second one, number 24, would be line 1 is 3 comma negative 4 and negative 1 comma 4. And then the second one is 2 comma 7 and 5 comma 1.
Slope of line 1
is 4 minus 4.
Okay, just go ahead and give me, yeah, no.
4 minus negative 4.
There you go.
Awesome. And then also,
one of the biggest mistakes in algebra, really, is dropping a negative sign. In other words, it was real close to drop that negative, one of the necessary negative signs. And boy, if you drop one, you're going to get it wrong because you're going to have the wrong sign. So you have to make sure you pick up every negative sign that you're supposed to have. And
all right.
What's the denominator?
Negative 1 minus 3.
Yeah, make sure you go in the same order. And what is all of that reduced to?
8 over negative 4.
Which
so negative 2.
Negative 2. Okay. And then slope of line 2
is 7 minus 1.
Yeah, notice that in line 2, it doesn't matter which way you go, you're going to have exactly one negative sign.
Yeah.
So 7 minus 1, might as well go that way. What's the bottom?
Yeah, and then 5 minus 2.
That's what
you do. 2 minus 5.
Yeah,
Sorry.
In other words, it's very tempting to want to do 5 minus 2 because now we don't have any negative signs. But the problem is you have to have the right sign. So you have to go in whatever order you went with the y's, you got to go in the same order with the x's.
Okay.
And that's 6 over negative 3, that's also minus 2.
Okay.
So line 1
these are parallel?
Parallel to line 2.
Okay.
And in terms of verbalizing this, actually one can learn quite a bit from verbalizing in an online session, merely because you don't get to do much of it in class. Am I correct? I mean, how often do you have to stand up and verbalize a problem?
Yeah.
So, and one does actually learn from verbalizing on how to properly think about it also. When you define a line, what you're doing is giving me 2 points. And that's all it takes to define a line. Any 2 points, okay? because if I connect those 2 points, that's the only thing about that line. I can also define a line with 1 point and a slope. So that's all the minimum you need to define a line is either 2 points or 1 point and slope. So when you're verbalizing this first line, it's made up of these 2 points, 3 comma minus 4 and minus 1 comma 4.
Okay.
Okay. Now, as I said, it wouldn't be bad for you to go ahead and send me a picture just so we get that locked into your smartphone. And then when we have another session, if it is online and you need to send me a picture, you'll have been through it once and your camera will remember it, and you'll just have to type the first 2 letters of my name.
Okay.
So do you have any problems that you can take, that you'd like to take a picture of? Send it to me and spend the rest of the session working on those.
Sure, yeah.
Go ahead and do at least 1 page. And as I said, I have 3 pages that probably fit right in with what you're currently doing that I can bring up, but I think it's definitely worth going through this process.
Okay, so what number am I sending it to?
I want you to send it to my email. And that way I can bring it up directly on my computer here, as opposed to my phone where I would have to forward it to my computer. Here's my email address.
Okay.
Like I said, once you type this in here once, it'll memorize it, and you'll just type DA next time, and it should bring it up, or bring up a bunch of options you can choose from at least. You know how to take a picture and send it to an email, right?
I'm not sure. I don't see the attachment.
Good. What kind of, I mean, this is a learning experience. What kind of phone do you have? Is it iPhone?
I got an iPhone.
iPhone?
Yep.
Okay. The only thing you have to make sure, and we'll check it out here today, is that you get the maximum resolution on it. And I think it asks you when you're doing it whether you want the 1K or the 4K or whatever. Choose the highest resolution. I have had some iPhone users use the wrong resolution, and then when I bring it up on my screen, we can't really read in detail enough.
All right.
But, yeah, let's check that. And you just need to make sure you're in good light or use the flash. It's better actually to be in good light and not use the flash if you have a place where you can set that page and hold the camera about 12 inches away from it so that it kind of fills your screen, and then take the picture.
All right. It's sending to you now. So.
Okay. And it kind of takes a minute or two. Yeah, we'll make sure we can. Oh, incidentally, that control panel for GoToMeeting, you see where that orange rectangle is with the white arrow in it?
Yeah.
That's a toggle switch for minimizing and maximizing it. In other words, I don't know if yours is probably maximized still. Go ahead and hit that orange arrow and you'll see what I mean. It shrinks it way down so that it doesn't take up as much of your desktop.
Okay, yeah.
And then if you click it again, you can maximize it, although there's no need to really have it open. Once you begin the session, unless I'm sending you like a link in the chat box here, you can always leave it closed and then you'll have more room.
Okay.
Okay, you sure you sent it? Did you put the 1949 in?
Let me check.
Yep, there it is. I'm sorry, I just didn't refresh, so it hadn't on its own. But there it is. And I can tell just by looking at it that that's good resolution. Let's have a look. And Pretty amazing stuff. Wouldn't have been able to online tutor 10 years ago. I mean, really, it requires the smartphone because it's so easy to take pictures and send them. Boy, look at the resolution on that. You must have a good iPhone.
Yeah.
You have a 6?
Yep.
Wow, that is great. Good light, too. Did you use a flash or did you just take it in good light?
Oh, I just moved over to the window. That's all.
Yeah, that's where how I input an awful lot of stuff that I have in books that I want on my computer. I have an enormous database of problems, whether it's geometry or through calculus on my computer. So in some aspects, it's easier for me to do an online session because I can bring everything to the table. Whereas if I go out to your house, I only can bring 1 or 2 textbooks. So depending on the material, there's that added thing. Okay, shall we do these exercises?
Sure. Could we start with 20?
Yeah.
Awesome.
What's the relationship between 73 and x? First of all, what are they called? Because that is, even though that's not something you have to remember forever, it is something you're going to be tested on in your geometry class. Are they alternate interior? Are they corresponding? Are they consecutive? Are they alternate exterior?
Consecutive interior.
Good. Actually, I think that's the only consecutive is interior.
Okay.
Maybe this angle and this angle would be considered consecutive exterior, but I don't think so, because consecutive implies next to one another. So what is the theorem say about consecutive angles?
They equal 180 degrees.
Okay. One talent that you're going to need really good to be good at geometry is the ability to subtract from 180. Because you have to do it so frequently. So
x would be 107?
Yeah. Did you need your calculator for that? Or?
Oh, no.
Good. If you can do that mentally, that's going to be really helpful for you in geometry. Okay, what can we say about 21? What kind of angles are they?
They're alternate exterior.
And what are they?
Obtuse. They're both obtuse. So
what does that mean?
They're both more than 90 degrees, and they're equal to each other.
Equal. That's the most important thing. It's really not the fact that they're obtuse that's important, because you can read that one to see that it's obtuse. It's that they're the same. In other words, alternate exterior angles are the same. So what's the algebra equation that fits that problem?
X equals 147 minus 14.
Okay, yeah, if we were to start it at the scratch, that's what I would do. And then, of course, after the first step, we get this, and we've solved it. So, now, once again, with parallel lines, you have the theorems that say if these two lines are parallel, then these two angles are supplementary, or this one is equal to that one. And the opposite also is true. In other words, if we know this angle is equal to that angle, then that means M is parallel to N.
Okay.
So it works both ways, always. Well, not always, but with most geometry theorems work both ways. What equation can I write here? What are these called? And this angle applies to this one up here. Knock this one down.
Yeah.
If it was applied to this one down here, what would they be called?
They're consecutive.
Vertical. In other words, whenever you have two lines cross, 1 is vertical to 2, and 3 is vertical to 4.
Okay.
If that 2x plus 20 was for this spot right there, then I could say it's equal to 3x.
All right.
These aren't called the same. In other words, one's exterior. So what do you know about these two angles?
They're supplementary.
Yeah, that's the thing. When you have a transversal, you either have equal or supplementary, and that's it. This is the acute angle, that's the obtuse angle, so they have to be supplementary. Let's make sure your algebra skills are up to snuff. Supplementary means add to 180. Next line.
You could add 3x and 2x together and subtract 20 on from 180
Okay.
on both sides.
So just read the next line. That's, in other words, if it's really complicated and you need to explain what you're doing, fine. But this is easy enough that if you just read the next line, then I know that you know what you're doing.
Okay. So just subtract 20 from both sides, I guess?
Well, the way you expressed it the first time was add the x's together and subtract 20. So I can do those two steps at once.
Mm-hmm.
And now finally,
uh, 160 divided by 5. So that'd be...
And that one, I don't care if you need a calculator for that. That's fine. That's not something you need to be able to do in your head.
So that one's 80?
32.
From...
160 divided by 5 is 32.
Okay. Yeah.
Okay? Which means, and this question said, what value of x makes these two lines parallel? Well, it's 32.
Okay.
Okay, it makes this angle 96 degrees, obtuse, and it makes this angle 64 plus 20, 84 degrees, acute.
Okay.
They actually haven't drawn that to scale. That's a lot bigger than 96 degrees. Okay. Slopes, I think we've covered. You get slopes now?
Yeah.
And there's really only two things about slope, and that's whether they're parallel or they're perpendicular or neither. Why slope is so important is hard to know when you're in geometry, but it turns out that all the way through calculus is slope. The slope is the most important word in calculus. Only you're talking in calculus about the slope of a curved line and a line that's tangent to that curved line. So, but that's why slope is important. And in geometry, you're just dealing with the slopes of straight lines.
Okay.
Okay, let's see here. Yeah, that's a great picture there. Let's see, we're going to 12:30, is that correct?
Sure, yeah.
I wasn't sure. Where did I put these three files I got? Maybe here. Yeah, I did. See, this must have been...
Oh, yeah, that's my homework for, I think,
Samsung
Thursday.
phone. This isn't quite as crisp as yours. Although I think he has an iPhone also, the kid who sent me this. But he could have an older one that doesn't have as good a camera. We might as well look at these. Agreed? I mean, is there... And you can't completely forget proofs yet. In other words, throughout Chapter 3, they're going to continue to ask you to prove stuff with parallel lines and perpendicular lines.
Okay.
And parallel lines with transversals and stuff. So once you get beyond chapter 3, you tend to not do any more proofs. Some geometry teachers will, put a proof on your final or whatever, just to torture you. But it's worth going through these. First of all, number 1, what's the shortest distance there?
AB.
Parallel lines? Right. Why is it shorter than CD?
Because it's a right angle.
Yeah, and we don't know that CD is perpendicular. It looks perpendicular, just like AB does. But the fact that they have not put the right angle there means that we don't know it's perpendicular. So the only one we know is perpendicular is AB. Obviously, EF and GH are slanted, clearly longer distances.
Mm-hmm.
Write the theorem that justifies the statement. Here's where I want you to look in your book and find the page. All your theorems are in green boxes. I don't know. I think it's in your section 3.6. Let's see. This says 3.6 at the top of it. But I'm not positive this is from your book. This might be a different book than yours. And it's a Chatfield student, but I don't know if he's using the same edition.
Yeah, I have it right here.
Okay. Can you find the page near these exercises, probably prior?
Okay.
And there are 3 theorems. And I'm not sure what your numbers are. I think they might be 3.7, 3.8, and 3.9.
Yeah, I have 3.8, 3.9, and 3.10.
Okay. And does 3.8 say if 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular?
Yeah.
That's what you would write to answer number 2. And I don't mean theorem 3.8. I mean just if 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular.
Okay.
That's justify. Write the theorem that justifies the statement. Well, notice that picture is exactly the same as the one in your book.
All right.
Okay?
So,
same thing with 3. The next theorem. And make sure that as you read those, you understand them. In other words, you understand the essence of what they mean. This one means is that if that's equal to that, I know they're supplementary, so they have to both be 90 degrees. That makes a parallel line.
Okay.
This one essentially says 4 and 5 are complementary. What does that mean?
That they equal 90 degrees.
Okay. So if you look at theorem 3.9, it says if 2 sides of 2 adjacent acute angles are perpendicular, then the angles are complementary. Well, angle 4 is an acute, angle 5 is an acute. They're 2 sides of 2 adjacent angles, and there's one side, there's the other side.
Okay.
If that total angle is 90 degrees, then those 2 sides are perpendicular.
All right.
And finally, number 4 should be your 3.10. See, in my book, it says theorem 3.3. And we even have the same book, just different edition. But number 4 is justified entirely by what theorem 3.10 says. And that's pretty easy to understand. If you have 2 angles or 2 lines that are at right angles to one another, you end up with 4 right angles.
Okay.
That's all that we need to do for theorems for the moment. What's angle 1?
Angle 1 is...
Another skill that's not bad to have is being able to subtract from 90. It won't come in as handy as being able to subtract from 180, but on problems like this, it's very handy.
So angle 1 is 25.
Okay. Number 6, what's angle 1?
90.
Number 7.
Angle 1 is 52.
Uh-huh. How would you show in number 8 that M is parallel to N?
Their bisector is 90 degrees on both of them, so they're parallel.
Well, this isn't technically a bisector, but it's a transversal.
Okay.
And according to the theorem from number 4, this one right here, if we have one right angle, then we have 4 right angles up there, we have 4 right angles there. That means that line T is perpendicular to both M and N. It also means that this angle is perpendicular or 90 degrees, and so M would have to be parallel to N if you found this case.
Okay.
What would be required here to prove that the two lines are parallel? In other words, you don't need to give me a 2-column proof. Just tell me the essence of what you would do.
X is an alternate exterior to the 90 degrees, so X is equal to 90 on both sides.
Okay. And now we have this picture. Right?
Okay.
In other words, the moment you discover X is 90 degrees, because you have a linear pair, so you know they're supplemental, since they're both called X, you got 2X equals 180. X has to be 90. And we've just shown how if that angle is 90, these two lines are parallel.
Okay.
And over here on number 10,
if one side of T is equal to 90, then X also has to be equal to 90 because they're supplementary.
Okay. And the moment you know that that's 90, we have this situation from 8. We already showed how we proved that that's perpendicular. Okay. Let me just have a quick look at some of these others. Yeah. In number 14, there's nothing that says that AB is equal to AC.
Okay.
All we know is that that's a 60-degree angle. AB doesn't have to be equal to AC at all. Usually when two lines are equal, or two line segments are equal, they put a hash through it. In other words, if I wanted to indicate on a drawing that something was equal to one another, maybe I'd draw a triangle, and I would say there's a hash mark there and a hash mark there. Okay, that means those two sides are equal. If I want to say angles are equal, I'll put a little curve mark, that's equal to that. But it's not equal to that. In other words, that's a right angle. You might have the situation, let me just explain a little bit more what I'm talking about, where you have two triangles. One's a bigger version of the other. And I would say, well, that angle's equal to that angle. This angle is not equal to this angle, so I'll use double. But it is equal to that angle over there. And finally, this angle here, I got to use a triple because it's different than either of these other two, but it's the same as that. And because all three angles are equal for both triangles, these two triangles would be similar. Not that you're there yet, but that's coming up next. Congruent and similar triangles. Let me go to my next page here. Good problems we have here. What can I say? What equation would you write regarding those two angles?
X plus 77 equals 90.
Okay. How about here?
x minus 5 equals 90.
And here?
Then 3x minus 9 equals 90.
Okay. We'll skip the picture problems. I'm not a huge fan of picture problems. I mean, it's worth knowing that we know these two lines are parallel because that's a right angle, that's a right angle. Proves this line's parallel to that line.
Okay.
The problem is that the principle can really be illustrated better by a drawing than it can by a picture. Notice that they had to superimpose these right angles onto the picture. Well, that right angle combined with that right angle means that line is parallel to that line.
Okay.
Let's go to 21. Which of those four statements are true if C is parallel to D?
Is it B?
Make sure there's not much difference between the first three statements, is there? In fact, when you first look at it, you say there's no difference between them. Well, see if you can find the difference. Find Waldo. I jokingly say that because finding Waldo requires attention to detail. You have to find the one thing that makes A different than B, different than C. What is it?
It's that it has the equal sign.
Okay. So what has to be true about angle 1 and 2?
They equal 90 degrees.
So A is the answer.
Okay.
Not B, which says they're less than 90, or C, which says they're greater than 90, or D, which says cannot be determined. And that's almost never the answer. If I'm tutoring kids for the ACT, I always tell them, never guess that. There'll be some questions that the fourth or fifth choice says cannot be determined. Cross that off of your list of possible answers. Never seen an ACT test that had that as the correct answer. This can be a little tricky. Like 27. I
27.
did it the hard way. Yeah. First of all, let me look at 23 and 24 to see if we can find an easy one to start with.
Okay.
What's the distance between the parallel lines in 23? Not 4 and change. In other words, you can't measure from there to there.
Okay.
You have to make a perpendicular line between the two parallel lines. Same thing with 24. The distance is not from 2 to 6, is not the distance between the two parallel lines. It's from this point to that point.
Okay.
Okay. Let me think for a second. Yeah, let's do 24. That's a little easier than 27. And after we do 24, if we still have time, we can do 27.
Okay.
What do we have to do here? Let me see if I can recreate this. We've got that point, straight line, and then we have this line here. Let's make our perpendicular from this point to that point only because the xy coordinates of this point are simple. One of them is 0.
Okay.
Okay? Rather than picking a point here and trying to find the perpendicular like that. Okay? In other words, make math as easy as you can. I could have picked this point over here. Same reasoning. One of the coordinates is 0. So either of these 2 points, but let's work with this point here.
All right.
This is 2, and that is 2. What we need to do is the coordinates of this point right here are what?
2, 0.
2, comma 0. And we need the coordinates of that point. Right now, is all we know is that it's some x and some y.
Okay.
So, let's start with what we can figure out, which is they're parallel, right? What's the slope of this lower left line?
1 up and 1 to the left. So it's 1 minus 1.
Look at it and tell me what the slope is. It's 2 units up, 2 units and 2 units, right?
Yeah.
So it's rise over run. Never forget that formula.
Okay.
The rise is 2, the run is 2. So it's 2 over 2. So it's got a slope of 1, but is it positive or negative?
It's negative.
Okay, that's the key. And that's the way when you're reading slope from a graph, you don't need to use the official y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can just go down and over. That's your ratio, 2 over 2. And then look at it to put the positive or negative sign on it. And it's very important that you know. I think I did that drill with you, did I not? Where I drew a bunch of lines and asked you whether they were positive or negative slope, and you got every one of them.
Yeah.
Yeah.
Uh-huh.
So you don't have any problems there. What is the slope? And so the slope of this line is negative 1. What's the slope of this line up here?
Negative 1. Because they're parallel.
And what is the slope of the perpendicular? That's the key.
Looks like 1.
Okay, you're correct, but what 2 things do we need to do to get the slope of the perpendicular? And always think of it as 2 things, not 1 thing.
Find the rise over run.
No, you got to reciprocate it and change its sign. Well, in this case, it appears we only had to do 1 thing, which was change its sign. And that's because 1 is the only number whose reciprocal is still 1. No other number's reciprocal is the same as that number. Okay, if I say to you x equals 1 over x, x has to be 1 and 1 only. Okay, so for this equation, I know its slope is 1, and I know it goes through that point. I should be able to come up with the equation of that line. Once I come up with the equation of that line, then I can combine it with the equation of that line to figure out what that point is. Once I know that point, both the x and y coordinate, then I got to use my distance formula. And that's what makes this problem so hard, is that you've got to know a lot about slopes and perpendicular measurements and also the distance formula. Well, let's proceed with this thing. Equations of lines. There's 3 formats. The most common one is y equal mx plus b.
Okay.
Okay? Can I figure out the equation of this line using that? The other
I
is
think so,
the
yeah.
other is point slope format, but you may not have had point slope yet. And there's no reason to really
No.
get complicated by going there.
Right.
So what do I know? How can I solve this whole equation? And to solve this equation means solving for m and b.
Okay.
Okay,
So,
m is what? 1. So
yeah.
immediately I can write it like that.
And B is 2.
B is the y-intercept. What we are looking at there is the x-intercept. So I have to solve for b. But I do know that it goes through this point right here that I have circled. What are the coordinates at that point? 2, 0. So anywhere you see y, write 0. Anywhere you see x, write 2. And that's going to solve for b. So I would say 0 equals 2 plus b. Well, that makes b equal
-2.
2. And sure enough, if I were to extend that all the way to the y-axis, that's where it would cross at -2. But now I know the equation of that line. Go back in and we erase that. In other words, when you come up with the equation of the line, you always have your x and y still. The only reason we substituted was to solve for b. Once we did that, now we go back and put it back into the general equation, which is y equal mx plus b, using a proper m and a proper b.
Okay.
All right. So now how does that help? Well, we need the equation of this line, oddly enough, because we're looking for this point.
Okay.
Okay. Now, the equation of that line is also y equals mx plus b. M is -1. So it's that. Can you tell what the y-intercept would be if I extended that all the way up? Given that you know the slope is -1, and given that the x-intercept is 1, 2, 3, 4, 5, 6.
Okay.
What's the y-intercept going to be?
0.
6. Where is it headed? In other words, what I wanted you to do was to extend this picture so that if we extended that line, what would that be? And we know it would have to be 6. Why? Because it crosses there with x equals 6, and the slope is -1. So if I do rise over run here, I go from 6 to 0, that's the rise, and I got to go from 0 to 6 to get the run.
Okay.
Okay? The advantage of doing that is now I know what b is. Because I didn't have a point on this curve. Well, I had this point over here, so I could have done it the hard way. But I now know that b is 6 for that equation. So here's what we've got. We've got 2 equations. This one is the equation of the perpendicular line. And this one is the equation of that second parallel line.
Okay.
And remember, our goal is to figure out what x and y are. Once we have x and y, we will be able to use the distance formula to find the distance between these two lines.
Okay.
I know this sounds unbelievably hard, but this is, I believe, the easiest way to do this. Okay, if we want to find the intersection between these two lines, we solve that system of equations. If you'll think back to your algebra, you'll remember that there's two ways to solve a system of equations. There's substitution and there's elimination.
All right.
Substitution's by far the easiest. If you have y equals something and another y equals something else, well, these two y's are the same because we're on the same point.
Okay.
So I can now say x minus 2 equals minus x plus 6. Solve that for x.
So you could do x equals negative x plus 8.
Okay, that's step one.
And then, I don't know, you can't subtract x on both sides, right?
This is what I saw in our first session, and I was kind of surprised, because this is huge. You definitely need to learn this. When you are solving equations that have both variables and numbers, you want to gather all your variables on the same side, gather all your numbers on the other. Well,
Okay.
how do I gather my x's on the same side? What do I have to do to the right side to get rid of that x?
Oh, you add an x.
Add an x. So now I got 2x on the left equals 8.
So x equals 4.
4. And now we need the y coordinate of x equal 4. And I can use either of these equations, notice, because I'm trying to solve for that point, and that point is on both this perpendicular line and it's also on the one of the parallel lines. So if x equal 4, y equal 2.
Okay.
So that's my point right there, is 4 comma 2. Now, almost done. Thank God, because it's 12:30, huh? But let's do one quick last thing, and this is important. This is the distance formula.
Okay.
What is the distance between this point, 2 comma 0, which is right there, and this point, 4 comma 2? Well, it's basically the Pythagorean Theorem. In other words, that's the hypotenuse of a triangle if I were to draw it. So the distance is going to be the difference between the x's squared, 4 minus 2 squared, plus the difference between the y's squared. That's equal square root of 8, simplifies to 2 root 2. There's your distance between those 2 points.
Okay.
I was shocked when I saw that problem because of how hard it was, how much work you have to do to come up with it. But if you can do all of it, it really shows a huge understanding of all of this subject matter. Not only parallel lines, perpendicular lines, the distance between, how to solve simultaneous equations. A lot of math is in that problem right there.
Okay.
Okay? All right, Mark. What's on tap here for going forth? Do we know yet? Do you want to talk it over with your parents as to whether you want to try staying online, or you want to do maybe one online and one in person? I mean, your choice.
I'll talk it over with my parents and I can email you.
That'll work. Let me, right now, I think I have you scheduled. Gosh, hold on. I thought I had you scheduled for next week. You don't have anybody scheduled for next week. What am I looking at here? What is today? 26th. My schedule just disappeared. Oh. Huh. My gen book just screwed up. Hold on a second. Let me log out and log back in.
Okay.
Just I want to make sure that you have a default that I don't give to somebody else. I've never seen it do that. Presented me with a blank screen. There we go. So if I go into next week, I've got you down Wednesday at 4. Do you want me to leave that in there and then you can decide whether you want to do that in person or online? Or is there another time or day of the week that is going to work better?
No, that works.
That'll work. I will leave that. I will leave 4 to 6 reserved. And the moment you decide what you want, if you would let me know, because if it's going to be online, I don't need to leave this hour reserved.
Okay.
Okay?
Okay. So, do you prefer online or do you prefer in person?
Online works, yeah.
Online works?
Yeah.
Okay, so why don't you tell him now that online works?
Online works.
Is that a good time? 4 o'clock on Wednesday?
Yep.
Or 4:30?
4.
4? Okay. An hour? Ask him.
Sure.
It's up to you, really, whether you want to do an hour or a half hour or maybe do 2 half hours in the week instead of 1 full hour.
Can we do 2 half hours?
Okay.
Yeah. What second day?
Your second day was going to be, it's Mondays, I think it's the only free.
Okay. I think Monday is my only other.
Unless you want to do
day.
before Shallows. Shallows at 5. You could do a lesson on Thursday at 5, at 4.
Does a lesson on Thursday at 4 work?
Oh, no, because he has Wednesday.
Okay.
Perfect. It does. In other words, I can lock that up for you. So here's what I'll do is lock up Wednesday at 4 for a half an hour and Thursday at 4 for a half an hour. And so if you ever, something comes up where you want to change it, just let me know, email me, whatever. Try to give me as much advance notice as possible. But
all right.
That's all I ask. Okay. And one last thing,